Hello.
Hi guys, thanks for joining us. So sorry about the network error, but we're back and we hope you grabbed lunch. So today here with us Likian and Turnbull that you've met in the past few weeks. So today we'll start off with a notebook that Lik put together to show you more about the real life applications of what you've learned. And then after that we will go through the live poll and the live chat questions. And finally, we'll be sharing with you more about our thoughts on an article that we sent to you in Newsletter this week. So, over to Lik.
All right. Can you see the screen? Yes. I'm going to assume that you can. Okay, so this week, I believe you all went through lessons on how to manipulate and handle pandas data frames. And so what I thought would be very helpful would be if I were to come up with like a demonstration of maybe like the 90% of the data frame, the pandas data frame functions you ever need to do your cleaning for your data set. And for that, I prepared a notebook. You can see the link here on GitHub, so you can go there and download the notebook and then you can play with it in your own free time. Otherwise, I will just run through the notebook. So as you can see, it's a demonstration of pandas for data science. Right off the top, you import the things that you need. So obviously you need pandas, and is like industry standard to refer it to as PD. You also use NumPy, and then we refer to it as NP. And then below is for purposes of plotting and showing you how things are shown, displaying pictures. So first question is, how do you create data frames? So in general, there are three ways, and I'm going to show you all three. First, if you already have a data set on hand, you can just do pd.read_CSV if it's a CSV data set, or if it's different kind of documents, you can read underscore different things. So if it's like a pickle, you will read underscore pickle. And you can always check the documentation for the different kind of reads. And then boom. So if you enter that, I've showed you. So what this does is that it imports it, it assigns it to df_csv. So that's the data frame now. You can run functions on the data frame to get information on it. So in this case, I do .it, and we can see like the first 5 lines of the data. So you can do other things as well. If I want a random sample of data, I can do .sample, and then it just give me random numbers, randomly pick up data along the data set. And at the same time, I can change the number of samples under the data. So now I'm looking at 10 things. Next, sometimes when you're trying to do data cleaning, you might want to try and work with a smaller data set to see whether your function works instead of applying across, like 10,000 rows at one time. So you might want to create your own data set. And in this case, if you already have a NumPy array, you can just put it into a data frame. So from here, you can see I assign the NumPy array for array. And then I do a pandas.dataFrame. I put the name of the array, and then something else you have to do is to label the columns. So the number of things in the columns have to be equal to the number of columns in the array. And once again, let's see. So this is the array on top, and below is a sample of the data frame. I can do the same thing and hit, or I can just display the entire data frame since it's so small. Okay. So the last one, the last way to do it would be like sometimes if you're working with data from very disparate sources, and then they come to you in the form of dictionaries. And so it's not a CSV, it's a bit more unstructured. And so pandas also allows you to create data frames based on dictionaries. And so from here you can see I have names, I have gender, I have ID number, and I have a score for some random data set that I created. And you can create a data frame by inserting a dictionary, with the key being the column names and then the values being the list references. Right? And then if you were to run this, you'll see you put it into a nice pandas data frame. So now that we know how to make our data frames, let's talk about how we can access values within the data frames. So one thing you might need to do is, let's say I want to know what are the names of the columns. Because it's a huge data set and I've not seen it in Excel yet. You can run .columns, and that will give you all the things inside the column. So this is based on the Titanic data set that I uploaded in CSV just now. You can do .index, and what .index does is that it gives you the names of the rows. So if you can see in this particular case, the index goes 2, 1, 3, 4, 5, 6, 7, and that's because when I assigned it in the ID number, I put 2, 1, 3, 4, 5, 6, 7, and I set the ID number as the index. And so it uses this index to index the data frame. One thing you have to note is that when you set something as the index, the values have to be unique. They can't repeat. If not, it's not index anymore. So people usually use like emails or like IC numbers, but they're not supposed to do that anymore. Okay. If you want to convert your data frame back into an array, you can do that with .values. So .values takes the data frame out and just leaves you with an array. And this was the original array that we had previously. To access specific values within the data frame, there's two things called ilog and log. And I noticed in the Q&A sometimes people did ask questions about what they do. So ilog is for slicing, and I stands for index. So it's locating indexes. So in this case, I put column 2, and then column 2 means that everything from 0 up to before the second index will be collected. So in this case, you'll get 1, 2, and 4, 5. So because it's based on this array, this array, so this is 0, this is 1, and so it gets 1 and 2. And then this is 0, this is 1, so it gets 4 and 5. The other way of locating things is by .log, and log means locate. So with log, you're not restricted to index numbers. You can locate anything you want. So you can locate it based on the column name, you can locate it based on the index as well. So it's up to you really. And the main difference is that ilog uses index slicing, which if you have done your Python before, you know that it includes the first value and excludes the last value. But log does not do index slicing, it does locating. So it includes the first and the last value. That's the key difference between log.
So actually they have very similar functions. It's just like you would use them in different kinds of situations, right?
Yeah, absolutely. So you use ilog normally when you're trying to slice an array. And then when you use log, usually it's because you know like what column you want, or you know, or you're trying to take out a particular value. Or in the case of log, you can like select like everything that has a certain number or a certain value.
I remember when I first get started on programming, Python programming and data science, one of the questions that I always have is, why do we need such a fanciful command when we can do simple data manipulations on the Excel sheet? Like for example, inserting columns name, creating values. So when should we use Excel, or when should we use pandas, things like that?
That's a very good question. I started off using Excel so previously. It was very convenient, like click and drop. But the first situation where you start using pandas, or rather like Python in general, is when you have very, very massive data sets. Like sometimes when you have like a few 100,000 rows, the Excel will start to crash. But you can still do with Python. And also certain functions, it's just easier with Python, I would say. For Excel, it's there, but then you would have to learn how to do it, and then things are less constrained. So like in Python, you can say, okay, I only want certain types of values here and stuff. But for Excel, everything's a spreadsheet format.
Yeah, I think for me, one big advantage of using Python is that it's reproducible. Because I think in Excel sheet, a lot of time when you open an Excel sheet, especially if it's done by someone else, it's very hard to know, first of all, where the data is from, what data has been, what kind of methods or processing method has been done, what kind of manipulation has been done, right? So it's only get end product. But I think what's so good about Python is that because it's a programming language, right? So every steps of the data cleaning and processing is listed in the notebook itself. So whenever you open the sheet, you can actually run through the sheet to get the same result. I understand what's the exact steps and methods that the person took to arrive at the solutions. So I think this is when the Python notebook shine, because it gives you the clarity of thoughts on what are the steps taken to reach the results.
Yeah.
Okay, shall we move on to the next part?
Sure. So the next part, I'm going to talk about some useful pandas functions. And so now you're in a case where you've already got your data in your data set. You're trying to do some maybe data manipulation or some feature engineering to prepare it for your machine learning model. And you need to know like what's in your data, what exactly is in it. So these 5 functions have served me very well. In general, when I start a project, I would just type these 5 things into my Python notebook and just look at the results. So let's do exactly that. So first we look at info. What info does is that it tells you how many null values there are and how many columns and the types of the values. So like int64 means it's integer, objects can be strings, float will be floating point values. And with this you can see, there are some null values here because everything else is 891 and there are 891 entries, but there's only 740 integers. And so you know, okay, now I have to do something about it. Yeah. The next thing you have to look at is describe. And so describe is like info, but it gives statistical data. So you have the mean, standard deviation, maximum. And how this helps you is that you can use it to identify if there's any outliers. If your 75% is very small, but your max is very big, then you know, oh, I have some extreme values. Should I delete those? Should I apply some sort of mathematical formula to make it smaller, like a log transform, this kind of stuff. And it can also tell you if there are weird values. So like if there's a negative age, then you know, oh no, what's wrong, you know. So you will know how to deal with those. Next is this applies more for categorical data, and so the function is called nUnique, and it looks at the number of unique values. So in this case, under survived is 2 because the values are survived or died. So there's only 2 values. You can tell that there are 3 classes. You can tell that there are 2 genders. You can tell that there are 3 ports of embarkation, and so on and so forth. Another useful one is value counts. So this is when you want to zoom into a particular value. So just now I mentioned embark, right? So there are 3 embark locations. If you isolate the column and then you do a dot value counts, you can see how many of each category there are. So this can give you information if your categories are very balanced or if it's like very skewed. In this case, you see like almost like 80% of the data is in S, and then everything else is in C and Q. Finally, this is to encode data. So you have categorical data, but often when you run your machine learning models, they can't take in strings, they need numbers. And so what you might do is to convert categories into numbers. So with this, you change the type. So initially the type was an object, you change it to category, and then you can pull up the cat codes, and that will convert all the categories into codes. So in this case, male is 1, female is 0, and then that's how they will move.
So Nick, earlier you mentioned about feature engineering. So I think that's a technical jargon that people might not understand. So we want to elaborate more on what's feature engineering and how would feature engineering ties back to encoding of data.
Sure, no problem. So feature engineering is basically the process whereby you process your raw data and turn it into features, which is another name for columns, into more columns where you can give your model additional information. So for example, if I have some sort of linear model and then my features is like gender, your model can't take in male or female, but it can understand numbers. So when you apply feature engineering, you convert the male or female into a number, and then you use that number to inform your model.
So essentially what you're saying is that when you do machine learning, so a lot of the time, the models could not take in a string value, such as male or female. Right? In order for the information to be useful, we need to encode it, to put it into a value of 1 or 0. So it's only when this happens, you can feed these into the machines, when you make use of this data to generate some outputs.
That's right. So, merging and joining. I noticed that someone asked that question just now.
Yep, good question.
So, luckily I prepared the answer. Excuse me. So, there are actually like 3 main functions: merge, join, and concat. In my opinion, you can do everything with just merge and concat. So concat works in both ways. I'm going to let you look at this one. Let's see what water. Sorry about that. So, by choosing the different axes of your concatenation, you can either choose to make your data broader or longer. So in this case, I'm just concatenating the same data frame, so it's not very useful information. But if you are loading your data from two different sources, it can help to concat them to form one big data frame to do your work on. So merging is a slightly different story. In merging, you are trying to identify something in common between two data frames, and then joining these two data frames based on that common topic. So I find that for merging, pd.merge is the clearest way you can go because it allows you to state everything explicitly. So let me first orientate you to the two data frames. The first one is this data frame which I created just now. And then the second one is this gender data frame. So in this gender data frame, there's just two values, M male, F female. So in this case, I'll try to use the short form and show people what the long form word is. So you do a pd.merge, put in your two data frames. You can choose which column on the left and let it map onto the column on the right. And how is inner. So there are three main joints. There's inner, outer, and then left joint. And then there's also right joint. That's quite similar. So how inner works is that if you have data frame A and data frame B, inner finds the intersection of both data frames, and then it makes the joint. So it ensures that both sides will have the common value in the center, and then it fills in the data frame. And that's what you have to do if you have to map. So now if you see the data frame, the output, you can see under besides gender, there's the full spelling of the name gender. So another way this can work is if, for example, you're trying to do countries. So you have country codes and then you have the actual countries. So this will help people to see, oh, okay, this country means what code, stuff. It has more to do to help with helping you to view.
Like readability.
Yeah, exactly. So if you have any more questions about merging, feel free to ask in the comments and we'll try to answer them later. Finally, there are last two parts. This part, I'm talking about group bys and crosstabs, which are kind of similar to what do you do to them in Excel? Pivot tables?
Pivot table, yeah.
Yeah, so that's the closest thing. So group by allows you to aggregate your results along a certain variable. So in this case, I group by gender, I put .count. It tells me the number of each gender. I put group by gender .mean, it tells me the average value of that score attached to the gender. And then the last one is called crosstab. So crosstab is when you want to create an array where you have column A, column B, you want to see where they intersect and how often they occur. So you would normally use this in, can you think of any examples where you use crosstab? Kind of machine learning.
I think it's for processing data for basket, basket analysis.
Yeah, exactly. So for like shopping basket, like recommendation systems, you need to look at commonalities between certain features. And okay, so now we'll talk about iterating through the data frames. I think some of the questions here have also been asked in the previous comments, and I thought I'd just like clarify it here. There are many ways to iterate through data frames. There's iterrows, there's apply and lambda functions, and itertuples. Iterrows is easy to understand, but I would not recommend it for most cases because if you look at these three functions, they do exactly the same thing. I create two random data frames and then I add them together to form a third data frame. And you see if I run iterrows, it takes 5.3 seconds to add this to 2000 billion data frames. If I use pandas.apply and I apply a lambda function, it makes use of the vectorization within pandas, and it makes the code a lot faster. So how much faster? It's more than, I don't know,
20 times.
about 20 times faster. And then last but not least, you can also use iter tuples, which is similar to iter rows, but you get tuples instead of rows. And then you have to jump through a bit more hoops, but you can see that it's also faster than iter rows, although not as fast as apply. So in general, if you have large data sets, I recommend using apply.
Okay, but for a lambda function, as fast as it is, are there situations in which we wouldn't recommend using a lambda function?
If you're, I guess in general, if you can vectorize the entire column, so if you can just say add row A to row B, you will do that. In a lambda function with dot apply, you are still doing things row by row, and so that is still slightly slower. So this is only the case if you have to do things that are row by row. So if you're trying to aggregate things or something like that, you will use lambda. But if you can figure out a way to do it with just matrix multiplications, then that will be the fastest.
But make 5 seconds and 200 seconds. That's a small difference.
Small difference to you, but but yeah, and it's small difference when you're doing with a very small data set. I mean, there's only 2,000 values at these two columns. If you have 10,000 values, it will be 25 seconds, and then that starts to have an impact.
Especially when you do machine learning modeling, right? So I remember yesterday when I was doing some machine learning modeling, my whole computer just hang for like 5 minutes, because it's processing all the data.
Yeah, so you really need to be careful. Once the data gets big, all your problems get big.
That's right.
Yeah. So that's the end of this. Feel free to pop the notebook, and if you have any more interesting things you can do with your pandas DataFrames, share with us, and then maybe I'll edit it.
Yeah, just to explain, forking of notebook is basically cloning of notebook. Just basically cloning. So that's a technical jargon we use on GitHub. So by forking notebook means that it's the clone notebook and maybe download it into the account of your computer.
So they can play with themselves.
Yes, basically, Okay, if you have any more questions about next book, you can also ask us in the live chat, and we will try our best to answer you. Okay, so shall we move on to the questions that were posed in the live poll?
Yeah, sure, let's do it. Those would be here.
Yes,
So, sorry, I thought you read present. Okay, so question 1.
Just backtracking to the chapter on importing data from websites using beautiful soup. What if the site uses JavaScript and the data is not immediately available in the HTML source page? Are there any Python packages that deals with this situation, and what are your experiences?
So I've done a bit of web scraping in my past, and it is true that certain sites, especially the social media sites, don't really like you to use like requests and to put all the HTTP data down. So they'll put things in the JavaScript format to try and make things slightly more difficult for you. And in that case, using your request library will not work. So in my experience, what worked for me was that I used, I can't remember what I used, but it was a web library. I use it to open a browser, like Firefox, and then I use that browser to open the web page, and then I grab all the HTTP and JavaScript data from the page, and that helps you to get around the problem. But the trade-off is that that's much slower than just using a HTTP GET request, and of course, at the end of the day, you still have to respect that website's privacy policies about web scraping.
So Nick, is it legal to scrape a website?
That's a good question. I think it depends on the website's policies and the terms and conditions of use. Usually the website will have some sort of metadata that says whether it's okay or not to crawl the data, and I think it's called robots.txt. Or that they also give the same information to web crawlers, and then the web crawlers will decide whether or not to go through the website to scrape the data for analysis.
Yeah, I think that's something to be very careful of. Make sure to privacy policy in terms of use before you decide to do any scrolling on a website, because yeah, just be careful.
Yeah, and it never hurts to just send the owner an email. For smaller sites, I think they would be more than happy to respond, because their concern may not be about the website being scraped, but that if it's a small site, they are hosting it on a small computer. If you send them 1,000 requests, they're going to be bombarded, and then the website will crash. So if that's the case, they might just give you the whole data set in a CSV file. So yeah, so be nice.
Yeah.
And I think for big website like social media, Facebook, Twitter, they have their own API which you can use to actually download the data bigger, right?
Exactly.
Yeah. So always check what's available through the website, because sometimes the service might require you to pay someone, because otherwise it will be illegal for you to screw the website. So be very careful about doing this.
That's right.
Okay, let's go to the next question. The two ways of referring to a column, either df call name or df dot call name. Is there any situation where only one of the two ways would work? What if the column name itself contains a dot?
That is one of two ways in which it will not work. And the second way is if your column name has two words, like big data. So if your column name is called big space data, you can't use the dot format. You have to use the quote format. So in general, I tend to use the word quotations, because it's just let me see at a glance what my column name is.
Yeah, and it's clear as well, I suppose, because if they are looking through lines of codes, a lot of time, if you see that the square bracket highlighting the column name, and this stands out. Otherwise, the column name might get camouflaged in the background, so it's very hard to spot the column names.
So basically, they serve the same function. It's just that the one with the quotation would work in most cases, right? And also makes it very clear for you or for your potential readers what the column name is. Yeah,
and one more thing also, I don't think it's a good habit to put a dot in your columns name. Usually you use underscore.
I mean, especially in Python where dot indicates like a function.
Yes, and especially if you are setting variables, right? So let's say you put like apple equal juice or something, right? So the variables, you have to use underscore. If you use dot in the variable assignment, right? Then the Python gives an error. You can't use dot, then assigning a name to the variables.
That's right.
Okay, so next question.
Good practices to do. Okay. When using pd.to_numeric to cast data, is there any way to choose whether to cast to float or integer type? Sometimes pandas might not make the best choice. What do you think?
I think for this, pandas will automatically decide based on the nature. If your data contain decimal point, then definitely it will be a float. If there's no decimal point, definitely it will be converted into an integer. Right?
Yep.
So this is usually the case.
That's right. So if you really want fine-grained control, instead of using dot to underscore numeric, you can try using dot as type, ASTYPE bracket, and then inside the brackets you can put integer or float or like integer 64, float 32, any kind of specific data types that you might want.
One thing, if you convert a float into integer, won't that give you an error?
Well, depends on the behavior of that method. Sometimes they will just drop the decimal place.
Yeah. So I think the best is to put, let's say, a round. So let's say if you want round up or round down the float to integer, you can put that in as well. So at least you have better control of how your data is being manipulated. Because the last thing you want is that drop off data, which decimal point is important, but you don't know what's going on. For example, temperature, 35.6 and 35 is a big difference in terms of temperature. So the decimal point is very important because you don't want to drop that out.
Right. Yeah. It's a big best practice.
All right. Let's see. When should I use pandas?
So when should you use pandas? I think you should use it as often as you can, because I think pandas is built on top of NumPy. Because I think for NumPy, if you use it, is it gives you arrays. It's very hard to interpret data, right? For pandas, it gives you like an Excel sheet format, right? There's a column, then there's rows, then there's like headers. So it's very easy to manipulate to join, concatenate, like to do manipulations on the pandas data frame. And a lot of the machine learning algorithms actually allow you to feed data frames from pandas directly into the machine learning model. So you don't need to do any further processing.
Yeah. Another benefit of pandas is that because you can attach information to the data, right? Because you have column names, for example. So whereas in NumPy, you might just have a array, you have no idea what the columns mean, you have no idea whether it's correct or not. But with a data frame, you can see, you can look at it, it looks a bit like Excel. You can see the rows, you can see the columns, and what everything is. So in general, I use that pandas whenever I'm working with data in mind.
Yeah, especially right at the beginning, right, when you're doing just data visualization, doing statistics, things like that, right? It's only those that end if you think there's a need to convert the pandas into another format, let's say tensor format. If you're going to use neural networks, for example, you need to convert it to a tensor data format, then it's only when you use other data format. Otherwise, I think pandas should be sufficient to do most of the things that you want to do.
Yeah, absolutely.
Highly recommend it. Okay, so you drop them in the live chat and they will be answered in the newsletter.
Yeah, our teammate on the other side is helping us to answer the questions on the chat.
So for today's last agenda, if you have taken a look at the newsletter that we sent out on Monday, you might have come across this article, Common Data Science Pitfalls and How to Avoid Them. So let's hear Nick and Tempo and see what they have to say.
Sure.
Shall we open up article?
Yeah, so let's look at the article. So let me just give a quick TLDR of the article. This guy works as a data scientist, used to do it in research, and then he went over to Microsoft to do it on the commercial side. And then now he's talking about kind of like the problems he's faced doing data science in the commercial setting versus in like a research environment where everything is nice and clean. In business, usually data science is not the focus. The focus is on your business outcomes. And so these are the business questions that drive your data science. So let's jump into the things that he talked about. The first one is about descriptive, predictive, and prescriptive analytics. And so the reason why this comes about is because at your high-level business questions, they usually don't tell you exactly what they want. They don't say like, I want an image classifier. They'll say like, oh, I want to improve sales conversion, for example. And so that brings you to the start of the escalator. You first need to find out, oh, what's happening in the situation right now? How does it happen? You know, what are some correlations between certain data that I have? And then from there, you try and move forward and create your machine learning model, and then you can answer the question. So I guess his point was that in a research point of view, you can go right straight to predicting stuff with minimal data cleaning or data collection, or sometimes like it's all been done by the guy before you. Whereas in the business, these questions have to keep being revisited according to whatever the business questions are.
So, Nick, at which stage do you think machine learning is needed?
Not necessarily machine learning, but data science on a broader side will be needed. At the beginning, you would be doing your exploratory data analysis or DA. You might use some unsupervised clustering algorithms to find connections between certain data sets. And so these can be considered machine learning, but it's more exploration. And only after that, when you try and decide, oh, what am I going to predict on, then that's when you build your heavy duty categorization or regression models. So
let's move down to the next sections.
So the next thing he talked about was proof of concept versus pilots. So I think this is something that we face or will face in our time as data scientists, which is where when someone asks you for proof of concept and they give you a data set, that data set is not usually all the data. So they cut the data out somehow. And most people that I know don't randomly select data from their data set. You know, if it's sales thing, they will say, okay, I'll just give you my entire sales for last year, and then you do some learning on that. And so that, in a way, is sort of you can use the data to build a proof of concept, but you never really know whether it will work when you use it, because it's only based on that 1 year of data.
Yeah, so I think for the participants, if they are planning to do some data science project after this AFOI module, I think it's very important to get the management to buy into supporting you in this endeavor, because if the data they are giving to you is it's not complete, the time taken for you to do the modeling everything based on the incomplete data. So even though if the data based on the modeling, right, it performs well, but once you launch it out in the wild, it might underperform, and because it might overfit to the data. So that brings us to the next topic in the article of overfitting and underfitting.
Yep.
Yes. So Nick, you want to talk about more about overfitting?
Sure. So the guy's thesis in this particular paragraph is that if you get an amazingly good performance right at the beginning of the data set, like more than 90%, then you should be very cautious, because there's a chance you might be overfitting the data. Sometimes, despite your best intention of keeping your train and test data separate, information not leak over, and then that's how you end up overfitting the set. And so maybe can you tell us a bit more about how this might happen?
Yeah, and what is overfitting in the first place?
Okay, so I think this has to do a bit of math, but I'll just talk on a high level concept. So basically, overfitting, it means that your modeling become too sensitive to the noise of the outliers, or it attempts to fit each and every outliers in the model. So if you look at the pictures on the screen, right, a nice model would be the curvature line that you're seeing, right, to separate the blue and the red. It could be, for example, to identify whether this is a dog or a cat, whether this will be a potential customers or not. But for model overfits, right, this is where you see the green line where it's trying to fit each and every model into the right category. When this happens, right, when you run the modeling on the training data set, which is the data set that the manager has given to you, it might perform super well, maybe 100%, right? Super. But once you launch it on unseen data, this is when the problem will come in, because the model is too sensitive. So any single point in the data sets that deviates from the norm, right, it will cause a lot of errors in predictions.
I think when we were working on the Titanic data set, there was a very good example of overfitting on the Titanic data set, where they included a lot of other variables such as the name or even the spelling, and then when we do it on the training data, it works very, very well. But then when you put it to unseen data where those names or spellings are not present, then the model doesn't know what to do anymore.
Yeah, so I think this is when you require a bit of math to understand how to deal with overfitting. So of course there are some methods, right? For example, you can do cross validations, ICV method. I think this should be covered on DataCamp eventually. And things like L1, L2 regularization on how to prevent or teach the model not to overfit too much. So I think this will be covered in the subsequent DataCamp modules, and I think we will be talking more in depth about the various methods to prevent overfitting in subsequent DNA.
Sure. So that's all for the article. If any questions about the article or any comments, feel free to talk about it.
So
I think that brings us to the end of today's session.
Before we end, I just wanted to say that we want to give you more time to ask questions on the poll. So we are going to, instead of open it on Monday, we will open it through the weekends. So open it on Friday night so that you guys can take your time and to ask any questions that you want. And we'll leave the poll open until right before the session. So feel free to ask us anything about anything. You guys have anything else to add?
No, I hope you enjoyed this session.
Yeah, sorry once again about the delay. All right, thank you.
Have a nice day.
Good day. Bye bye.